Alright, so we're talking about acids and bases and the reactions between them. Okay? That's what this unit's about. Now I'm kind of skipping over a little bit here. Normally I'd go directly to solutions and then go to acids and bases, but I want to try to spend a little more time with acids and bases. So we're going to do that first, and then we'll do a probably short unit on solutions, because we'll cover a lot of solution chemistry in acids and bases. Alright? So in our lab that we did day before yesterday, we simply did a very simple neutralization reaction, where we neutralized one weak acid and neutralized one strong acid. Okay? And it is the neutralization of acids and bases, or neutralization of acids by bases, or vice versa, neutralization of bases by acids, that give us a new definition of a salt. The chemical definition of a salt is the product, other than water, of an Arrhenius acid .
That means it's dissolved in water with
Arrhenius means we've looked in this class at two different definitions of acids, two different definitions of bases. One is Arrhenius, and the other is Bronsted-Lowry. That's what yesterday's class was all about. Okay? Of an Arrhenius acid and an Arrhenius base.
What's the first four letters of the Arrhenius?
ARRH. Okay? So let's look at an example. In the lab, we reacted hydrochloric acid. This was our strong acid in our first lab in this unit. And we reacted it with potassium hydroxide. The way that we learned to predict the products of reactions back in Unit 5 was we looked at the two chemicals here. We recognized those two chemicals as both being, in this case, an ionic compound and an acid. Okay? Two parts. This OH is a part, and the potassium on the front is a part. So this is a two-part chemical. Hydrogen on the front, chloride on the back. When you put together two-part compounds, what classification of reaction do you get? Double replacement. Further than that, you have to classify this in a subcategory. It was the only classification in Unit 5 for which there was a subcategory. And the subcategory here is acid-base. Yeah, it isn't that hard. We're in acids and bases. This is acid-base. This whole unit is on that sub-classification mostly. Well, there's a little bit of single replacement in here. Mostly it's the double replacement reaction that is the sub-classification under double replacement. The big category is double replacement, subcategory acid-base. Got it? If you don't remember that, write it down. If we react an acid and a base together, if it's an Arrhenius acid and an Arrhenius base anyway, it's almost always going to be a double replacement reaction. And that is a subcategory, part of the category for double replacement. Write it down. If you don't remember it, apparently nobody did because nobody spoke up. Everybody should write it down.
So, what you said was that when you have an Arrhenius acid and an Arrhenius base, then it's going to be a double replacement acid-base.
Yes, the big category is double replacement. That covers things besides this. But this is a specific subcategory within that larger category of double replacement called an acid-base reaction. We gave it another name. We said you could also call it a neutralization reaction. Okay? And so this is either, you can either call this acid-base or neutralization. All right? You need to know both terms. Neutralization means we're neutralizing, which is what you get when you put an acid and a base together. Acid-base basically means the same thing. Although it gets a little more complex with Bronsted-Lowry acids and bases, and then with Lewis acids and bases. All right, so in a double replacement reaction, how do I predict the products? What do I do to find the products in a double replacement reaction? Front of the first one, back of the second one. Front of the first one goes to the back of the second one. H2O. And what do we do to find the other product? Front of the second one, back of the first. And the front parts always stay in the front. Now, one thing I haven't done is to check for balance. I've started with a really simple one. We know that HOH is balanced, right? I hope. Well, potassium has a 1+ charge. Chlorine in the binary compound has to have a 1 negative charge. It's already balanced. I've given you one that's pretty simple for right now. And this is also going to be aqueous. You have to figure that out from, what do you use to figure out whether something's aqueous or going to be a solid? Huh? Solubility rules. Okay? Just because we finished in Unit 5 doesn't mean we can throw those things away. Still using them. All right. So, the product other than water. So we're eliminating water in terms of this definition. Where's water? HOH. So the product other than water of an Arrhenius acid and an Arrhenius base, I should say reaction here. Okay? So what's the salt?
Potassium plus.
You got it. Okay, so that's not so hard. Shouldn't be. Potassium. Is that what you're asking?
Yeah.
Potassium chloride.
So all we're doing is finding the salt?
Right now. Mm-hmm. Okay, so you're going to do this now. I just did the first one for you as an example. Now you're going to do the second one, or this in-class practice problem. Write the double replacement version of an equation in which acetic acid is reacted with potassium hydroxide, and label or identify the salt. That's what we just did with this reaction. This is for the other acid that we reacted with or neutralized in our lab the other day.